Yeah, good morning, everyone. So last day we just been started up a discussion talking about task parallelism, right? So I have just shown you how to write a I've already shown you how to write a program by using task parallelism. Okay, and in this case, two things have just been demonstrated, guys. One, how to call a non-value returning method and a non-parameterized method. Second one, how to call a value returning method and how to call a parameterized method which returns a value, right? I shown you all these three options to you. Okay, non-value returning methods, value returning methods, which takes parameters and which doesn't take parameters. All options are demonstrated for you to you how to call. Okay, fine. The next thing what we are just going to see is, I said you guys, what's it? We are just going to look into the concept of thread synchronization. The thread synchronization or the thread locking mechanism. You watch that in the videos. What is that? If in multi-threading, if multiple threads are trying to call different methods in a class, if multiple threads are trying to call different methods in a class, there is no issue. If multiple threads are trying to call different methods in a class, there is no issue at all. There is no issue at all. But if multiple threads are trying to call the same method, sometimes there is a chance like multiple threads trying to call the same method. In that scenario, compulsory, there is a chance of facing a problem. There is a chance of getting a problem. There is a problem. There is a chance to face your problems there. And guys, to avoid that problem, we are provided with the thread synchronization. We are provided with the concept of thread synchronization. The thread synchronization is what we have as an option here. Okay, so already the thread synchronization you guys have just checked out in your threading already. Already in the threading we have just been learned about how to do that, and today we are going to learn it by using tasks. How to do the same by using the tasks. Earlier you saw it by using threading, and today we are going to see by using tasks. Yeah. First, let us see this with the threads. Let us see the concept with threads. With the threads, how to do, let us see. Okay. We created a project. I think the name of the project is TPL project, right? Yeah, TPL project. Let me add a class. First, we'll see with the threading, guys. A simple method. Public static void display. A method, public static void display, a simple method. And in this particular method, the method name I given is print. Any name here, no issues. I'm writing console.write C sharp is the next line I'm writing console.write line object oriented. C# is object oriented. I have two separate statements. Means two different actions to be performed here. Okay. Now, let me come to main. I want to call this method for 3 times. Okay, call it print. I'm calling the method for 3 times. And all of you guys, you can just observe it. You're calling the method for 3 times. But guys, you are calling in a single threaded model now. You're calling them in a single threaded model. So it'll perfectly execute for you. C# is object oriented, C# is object oriented 3 times. And see, because you used right in the first line, right line in the next, you get the output on the same line. There are continuation actions, that's all. They're going to be continuation actions. So I got the correct output. But if I try to call these 3 methods by using 3 threads now, 3 threads now, how to call? Thread T1 is equals to new thread. Thread T2, thread T3. Next, T1 dot start, T2 dot start, and T3 dot start. And then T1 dot join, T2 dot join, and T3 dot join. Now the problem starts. You may get the correct output, you may not get it. See how it is happening. 3 threads are trying to access this now. So when one thread starts, if another thread starts, problem will come up now. See, we know that time sharing is there. Thread 1 started. In the given time, if it completes its work, no issue. But see, when the thread 1 started, it was able to print C# is. Meanwhile, thread 2 started off now. So time sharing control went off to thread 2, and luckily thread 2 was able to complete its work in the given time. Are you clear? Afterwards, what happened? Again, control came to thread 1, completed. Next control came to thread 3. You will not get the same output here. If you run like this, every time you will be seeing a different type of output. It depends upon your processor speeds and all the appropriate things. The same thing, if you remember, I demonstrated in the video with a sleep. With a sleep. No need. Sleep only to just give you some time. This thread was not able to run, so control goes to another thread to demonstrate that. I used their thread dot sleep. Some time period I just given it like this. Thread 1, thread 2, thread 3 all started. So printed off now. Everyone went to sleep now. So thread 1 completed, thread 2 completed. See, you are getting a wrong output. You won't get the output correctly. Writing this sleep is not mandatory. Just to demonstrate, to make some delay in the time, I demonstrated like this. But otherwise, you write like this enough. You can see that. You won't get right output. You may be getting a different output on different machines. Sometimes, luckily, all the 3 could show you C# is object oriented, C# is object oriented, C# is object oriented. Or it can show you a different kind of output. See now, our luck. What is that? In the given time, the thread was able to do its work now. So I got the correct output. If it's not able to do, and if second thread comes there, problem. Now again, yeah, see that you did not get the correct output again. So that's the issue with this. And to overcome this problem, what did I say? We just explained about a concept called thread synchronization. Thread synchronization. What is the thread synchronization? When one thread is trying to access a method, the second thread should not be given access to the method. When one thread is accessing the method, the second thread should not be given access to that particular method. And we call that as a thread synchronization, locking. How to do that? To do that, I said you the code inside the method should be put under a block. How? Lock, what did I write? This, lock this. When I say lock this, it is going to lock the method. What will happen? When one thread is trying to access a method, second thread cannot enter into the method now. Are you clear? When one thread was accessing the method, second one cannot enter into the method now. Are you clearer or not? Thread 1 entered. Until thread 1 completes the work, thread 2 cannot enter. It's just like a telephone booth now. What is that? One person entered the telephone booth, locked the door, and talking on the call. Until the person comes out, second person is not allowed now. Are you getting my point or not? So everyone has to wait in the queue. You have to wait in the queue, one by one, one by one. Okay? The multiple telephone booths, no problem. Every user can go to one telephone booth. But what is the problem here? One telephone booth, multiple users. Multiple telephone booths, multiple users. No issues here. The problem is one telephone booth, multiple users. Then the problem starts. Okay? But guys, listen, in the video, you already remember lock this is a code I explained there. But one thing I want to clarify you. What is that, you know? Actually, in C#, if you remember this point here, in C#, guys, if you remember, in the videos, I explained you with the static and non-static methods. In the videos, I all explained non-static. All are non-static. Because it is non-static, we said this here. Under static block, we can't use this, na? It is static. This means current class, na? You should write class name here because your code is static now. This is giving error. Did you notice? In the video, it worked, array, because in the video, the method is non-static. This will work, but here the method is static. This will not work. And remember, keyword this is not valid in a static property or a method or a static field. In static, you can't use this. We already learned. Only one place under static, we can use this. What is that? Extension methods. Only in one scenario for static, we can use this. What is that? Extension methods. Otherwise, in static, we can never use this. In the place of this, actually, what we should write? Class name here. What is the name of the class? Class file. And don't forget, generally, class names cannot be directly used. If at all you want to use a class name, we should always use an operator. What operator? Type of. Type of. Remember, type of operator will tell you the type of the given expression. When you pass it, it will tell you the type is complete qualified name. What is that? TPL project dot class 5 is what it returns to you basically. This is how you should write. If you're writing code in static, because all videos are shown with a non-static, tomorrow without confusion, if you go for a static block, how to write, that's why in the classroom I'm explaining all static. In the videos you have all non-static calling, and in the classroom I'm showing you static calling. Is that clear? Now will I get the correct output? Is there any chance of getting a wrong output? Earlier, see, when I don't use lock, sometimes correct output, sometimes wrong output you get. But now see, there is no chance of getting a wrong output anytime. If you want to make it delay also, and you can see how thread dot sleep make it delay, but still you won't get a wrong output. What happens? Thread 1 starts, printed C# is went to sleep, is not coming out. Thread 2, thread 3 are waiting in the queue now. Thread 1 wakes up, completes the work, comes out, 2 enters, again goes to sleep. 3 is waiting. 2 completes the work, comes out, 3 enters. Now see, there is no chance of getting an error. This is called thread synchronization. We already explained at the video there. And the same thing now can I do with tasks now? Yeah, you can do with tasks also. What code, sir? Same code only with the task also. Watch it. Let me add a new class, class 6. Now we are using threads and tasks now. Now let us go with task. Same code here. The method code is same only. Watch. Class 6 है class 6. Come on. Static void main. Task T1 is equals to new task of method name print. Next T2 T3 T1 dot start T2 dot start T3 dot start. Okay, next task dot wait all. T1, T2, T3. You can at a time call wait all. Come and run class 6 and see. Now also it is same now. Because I already said you this clearly. A task will create a thread internally. Working with the task is nothing but working with a thread. But directly you are not creating a thread. What are we creating? Task. To prove that only, I printed the thread IDs and shown to you already. Thread ID was printed for us. Okay. So if you want, check the code without locking. Comment it. Run. You again see wrong outputs in this. Unexpected outputs or unexpected behavior. Okay. Another way of writing the code. Task T1 is equals to task dot factory dot start new print. Array, this code is common for all. No changes to that code. Either this one or either this one. That's all. You see the correct output again because I just used the synchronization, the thread locking or the thread synchronization. Yeah, you got the correct outputs. Okay, now. Actually, when you're working with the tasks, how do you make them sleep, Like we can use thread.sleep also. But if you want to do with the tasks to make it sleep, means just like a sleep mechanism here is done like this. Task dot delay dot wait. It is not thread dot sleep. If you are working with the threads, we call thread dot sleep now. Here, if you want to make a thread dot sleep also will work here. But if you want to really make it wait, how to write the code? Task dot delay of the time period dot wait. Behavior is same. You can see behavior is same, but different way of writing the code. That's all. That will internally call thread.sleep again. Array, you can only call off thread.sleep. Anyhow, that is a static only na. You can only call off, or if you want, you can just also call task.delay of time period dot wait. Basically, this is a lengthy statement compared with thread.sleep. But option is there here also. This is how you write the code. Okay, na? In the future, completely if Microsoft removes threading, then what we need to use? Task only. Means we don't directly work with a thread. We only work with a task. In that case, thread.sleep will not work. So anticipating the future, they given you that option task.delay. Okay, now? Just a second. Okay. So this is the thread synchronization what we have. And the next thing is there is a new concept here. There is a new concept that is available for you in task parallelism here. In the TPL, in the tasks, what is it called? Parallelism. The name of the concept is a task parallel libraries. So basically here we are just been provided with a concept called parallelism. What is parallelism? Actually, parallel execution. You know what is meant by parallel? Means Both are going to run for you in parallel. Parallelism means both are going to run for you in parallel. For example, we take a for loop. In a for loop, I just want to process a huge volume of code. In a for loop, I'm running a loop here. The loop runs for 1 lakh times. Yesterday, see, we have just tried to concatenate 1 to 1 lakh. Remember that or not? The loop runs for 1 lakh times. Generally, what happens? One thread will create and one thread will run the whole loop. We have been provided with a concept called parallelism. In parallelism, what it enables, the loop, the for loop can have multiple threads in it. And multiple threads will be running the loop to you. Are you clearer or not what I said here? Are generally a for loop or a for each loop, if you take for or for each, one thread runs the whole loop. The loop may be for 10 values or the loop may be for 1 lakh values. If 1 lakh also, one thread only will execute. So if one thread is processing the whole loop, it will take time. To avoid this, they introduced the concept called parallelism. In the parallelism, you can have multiple threads running a loop. So basically, we have two new loops now. For loop and for each only, but they are called parallel.for and parallel.for-each. What are the two? Parallel.for each. What will happen? In parallel.for, till now, whatever we are using now, they are sequential for each. Means one by one, they execute for you. Now what are we learning? Parallel for each. What is parallel for? Parallel for means is a for loop that have multiple threads in it. Parallel for each is also same thing. A for each loop with multiple threads in it. So how to use them in my code? Okay, I'll show you. Let us run a loop which runs for 1 lakh times. And first we'll run the loop by using for loop. Check our time. We know how to check the time now. Stop clock. Same way, let us also use parallel for. And we'll just try to check in the difference in the time what is taken by a sequential for loop and a parallel for loop. I hope you guys are clear what I'm showing you. Then we'll demonstrate, then we'll discuss about that in detail. But that's what exactly I wanted to show you now. Okay, you guys observe. This is the syntax of a sequential for loop, right? Sequential version. For each, I'm showing you for each. Same way for also I'll show you. Sequential for. How do you write for each? Where item in? The source collection, whatever is your collection, the source collection. Next, process item. Here you say parallel.for each. Directly, your source collection, your collection name, comma, item, lambda expression, process. What is this item? The item is nothing but a variable here. Where item? Array for each int I in. Say, you have an array, integer array, ARR. How do you write? For each int I in ARR. Correct na? How do you write here? Parallel.for each, ARR, comma I. That's all. Oh, no need int I, no need. For each ARR, comma I. I is your variable now. I is your loop variable. Okay? I'll show you practically so that you'll understand it much better. Let me show practically, guys, so that you can understand this much better here. Okay? The parallel, the sequential and the parallel equivalent, both the two things I'll show you. Let me add a new class. Class 7. Guys, remember this code? Just a minute. Yesterday, in the last session, I shown you. Concatenating from 1 to 1 lakh. How much time will this take? Don't know. I want to find out. How? Stop clock. Take a stopwatch and find out. How to use a stopwatch? What is the namespace? System.diagnostics. What is the class name? stopwatch. Create the instance of the class. Next, start. Come below. Stop. Yeah. The watch stops and the loop runs and the stopwatch stops. Finally, we can check it out how much time has been taken to execute this code now, right? Read that. Time taken to execute the code by using sequential for loop. How I'm printing SW1 dot elapsed milliseconds. Means how many milliseconds are elapsed. See, generally, I was telling you when I was talking about user controls, remember when you talk about time, we never say completed time. That's wrong English. Elapsed time. Are you clear? So elapsed milliseconds means how many milliseconds it has taken. Shall we write the same code by using a parallel for loop now? Parallel for each. Come on, just now I shown you parallel for loop, whatever it is here, anything. I just given the syntax for each there. For also can you guys. How do we write the same code by using a parallel for? Okay, watch it guys, all of you. Parallel dot for. Here. Int from inclusion, int to inclusion. What is that? Start from where, end at where. And the data type is integer C. So directly I can say 1 comma 1 lakh or 2 lakhs because 2 lakhs is what we use. Okay, let's, it'll take a lot of time. Let me decrease it. 1 lakh. See, generally when you write for loop, int I is equals to 1, I less than, no need here. Just watch it. Start with 1, I less than or equal to 1 to 1 lakh. Here also 1 comma 1 lakh. Oh, no need to declare anything. No, by it's a method now. It's a method now. Yeah, for is a method. Array for is a method now. Present in parallel class. Are you clear? Now you're not writing a for directly. You're calling a method now. For this method, the method takes parameters. What is parameter? First parameter, int starting. Second parameter, int ending. Okay. Afterwards, put a comma, then a lambda expression. You can use a lambda expression and you can write your code inside of it. You can write your logic inside of it. You just use a lambda expression and you can just write the code in it. Just a minute, just like we declared str1 here. Let us declare str2 here. str2 is equals to str2 plus I. Okay. Should use I and then I should give, I think. Yes. Syntax is that. Just observe it. That's a method. 1 comma 1 lakh comma parameter name lambda expression. What is that? Anonymous method. You learned, remember now with the delegates, we can just use the anonymous method, lambda expression, and we can write the logic inside of it now. So we're just going to write the code in this type. So this also will process you from 1 to 1 lakh. Concatenation will be done from 1 to 1 lakh now. But let us just find out the time taken by this now. How's that? One more stop clock. Guys, one more stop clock. SW2, sorry. SW2 dot start. SW2 dot stop. What is this, guys? Parallel for loop. SW2. Iteration cannot be changed here. Iteration cannot be changed here. That option is not available here. Iteration cannot be changed. Okay, just have a look. Run the code. Let it execute, and finally T1. Let's go. Check out yourself. How much time is taken by sequential for loop? 15 seconds here. 15 seconds and 15, 15403. Somewhere around between 15 to 16 seconds. How much time has been taken to execute a parallel for loop? Less than 2.5 seconds. Less than 2.5 seconds. There it is. 15.5 seconds around. But here, 2.5 seconds. So that much faster? Yes, it is. It is that much faster. And guys, remember here, it's not like one thread which is going to process this request here. It is going to be multiple threads which will be running behind the skin. Sir, can we see them? Yes, we can. We can see them. We can see the threads which are going to process the request also. I'll show you. We can see them. Did you understand? I'll show you. Multiple threads are executing on the code. I'll show you. But did you understand the difference? This is called as parallelism, data parallelism. So adopting this, they are just given us two things. One is parallel.for and the second one is parallel.forEach. Parallel.for and parallel.forEach is what Microsoft has provided for us right now. We can just now use the parallel.for and the parallel.forEach loops to execute your code. I hope you are clear, all of you. We can either use a parallel.for or we can either go for using parallel.forEach. Both the two things can be used for executing. So I shown you a for now. Shall I show you for each also? We take a for each also? Yeah. Watch. Okay. So my idea is to show you how to write a parallel for each. Second thing is multiple threads are executing in the code. That's what I want to show you. Okay now? Write a main method. In this, just declaring an array. Declaring an array, guys. Values 1 to 40. 1 to 40 values inside the array. You put how many you want, more than 40 also. Okay, let me put some 50 values. How many you'll put is your choice, no issue. Yeah. Which has been created a for loop with 50 array with 50 values. Can we print them by using a for each loop? Yes, we can. But for that, we need to define a for loop. For each loop, we need to define a for loop. Or you know how to print by using a for each loop. I don't require to tell you. For each int I in ARR. Okay. Console dot write line I. Here guys, I just also want to print the thread ID. I also want to print the thread ID. Both the two things I just want to print here. Just a minute. I will write the code like this. Thread ID. This will print your thread ID now. Next, I value. I'll print you I value. First what will print you? Thread ID. Afterwards, I value. Both will be printed. Okay now. Run this code once. There is no task parallelism, nothing here. Normal sequential for each loop I have just used. And you see the output. All of you can observe. What is the thread ID? 1. I value 1 to 50. Is the code clear? Okay, done. Now, I want to write the same code by using a parallel for each now. I want to write the same code by using a parallel for each. How to write? Parallel dot for each. First, pass your array name, ARR, comma, pass your variable name, I. Understood or not? Pass your array name and pass your variable name. I is the variable what we just have. Okay. And then we can just go for using a comma, lambda operator. Forgot. Correct one. No comma, directly lambda operator. Printing the same again. Printing the same again. I'm not doing anything. Just see the loop syntax, guys. Array name first, variable, lambda expression, and you can write off the code. Okay. So now you just execute. Now also it print you from 1 to 50. Just a minute. Just to differentiate the things. A line break, guys. Just added a line break. So outputs are separated. Now this is the first one. You have a line break. Now the second one. See here, 1, 2, 3, 4, printing all the values. Printing all the values. But sir, you're not getting them in sequence. Yeah, I'm not getting them in sequence because they're processed by multiple threads here. What's the thread IDs if you want? 1, 9, 5, 8, 3. Five threads are there. There are 5 threads which are processing the output now. So, sir, always only 5? No, yeah, I don't know. Sometimes 3 threads can be there, sometimes 10 threads can be there. It's not my control, but multiple threads are there. That's the thing I will tell you. 1, 9, 5, 3, 10. And now also we got the 5 threads. Now also we got the 5 threads now. And the 5 threads are just trying to process your output now. So is it clear? Multiple threads are just going to available for you in a parallel for each now. So to bring you parallelism to process means to make the things faster, they introduced us multiple threads. Multiple threads will work now. Because multiple threads will work now, earlier we saw that is faster and efficient. Yes or not? Now also tell me, for each faster? Sequential for each is faster, parallel for each is faster. Parallel for each. We already noticed that. Let's check it out once. Just now how we checked out. Let us check here also once. So we'll get up a clarity. Using system.diagnostics. Stopwatch SW1 is equals to new stopwatch SW1 dot start SW1 dot stop, and here I just wanted to print the message time taken to execute sequential for loop. Okay, na? Time taken to execute a sequential for each loop. Sorry, sequential for each loop. Same again. This one, parallel for each loop. Stopwatch SW2 is equals to new stopwatch SW2 dot start and SW2 dot stop. Same story, time taken to execute for each loop. So which one is faster, guys? Parallel or sequential? Parallel is faster than compared with the sequential. Okay. Yeah, how much time is taken by using the parallel for each loop? 221 seconds. Yes or not? So this should be more in case of for, right? Tell me. It is taking the same time now. It has taken the same time. Just a minute, not same time. Yeah, you printed wrong. Here we forgot to change. Let's say we printed the same output. Okay. Just a minute. Without printing it there, I will print both at the bottom. Both at a time we'll see the output. Okay, guys, have a look. Sequential for each loop and parallel for each loop. Sequential for each and parallel for each. See that? Which one is faster here? Sequential is faster now. Let's see for multiple times. Oh, wow. Sequential is a little faster. But earlier we saw that parallel is faster. Yes or not? What did we see, guys? Parallel is faster is what we noticed. But here it is showing you sequential is faster. We'll clarify. Read it. You'll understand. Depends on the work you're doing, guys. Depends on the work you're doing. You want to serve food for 1,000 people. You want to serve the food for 1,000 people. And you have 20 people there just doing the work. Yeah, it is faster. You want to serve the food for 10 people and you have 20 people to serve the food now. It will become a nonsense now. Are you clear? Do you understand me? Which class? You want to serve the food for 10 people, yaar, but the people to serve the food are 20 now. It will become a nonsense now. Am I correct? That's what. When your loops are bigger in size, then parallel. No, small size. At that time, sequential. So, just I want to show you this example is not to prove you parallel is faster. This example is just to prove you there are multiple threads executing in the code. Understood my point or not? Multiple threads executing in the code. Just to prove you that only, I have demonstrated this example to you all. Hope it is clear. Okay, fine. What next? Okay. The next thing, guys, is it is about task chaining. We have one more thing here called as task chaining. What is task chaining? I think, guys, with one thread, I wanted to call multiple methods. With one thread only, I want to call 2 or 3 methods. Generally, what I explained in multi-threading or same thing, one thread calling one method. Yes or not? But one thread, I want to call multiple methods. First one method, afterwards another method, afterwards another method. One thread should call me. Generally, main thread will do. But user-defined threads calling multiple methods, I did not show you. Did you catch my point or not? What I shown you in the videos or what I shown you till now is one thread calling only one method. But main thread is capable of calling multiple methods. First method, second method, third method in sequence order. Same way, sir, I want to create a thread on my own. With this thread, I want to call 3 methods continually. First method after execution, second method after execution, third method. I want to link all these things now. One thread only calling me all these methods. We can do it by using a concept called as chaining. We can do this with a concept called as chaining. Chain here, chain one by one connected to each other. Okay, how are we going to perform this? How are we going to perform this one? Okay, watch it, all of you. How are we going to chain the things? I wanted to write a method here that brings me the multiplication table of a given number. Just check it out. You know that method. Have a look on that. What are you doing here? You're printing the multiplication table now. Suppose if you give 5 here, if you give 20 here, it will print a multiplication table of 5 from 1 to 20. Same way, I want to write another method here which prints me the multiplication table in a reverse order. Reverse order means 20 to 1. Reverse order, not 1 to 20. Now it is 20 to 1. 20 is an example I taken, that's all. That is your choice. See now, this is going to print you the output in the reverse order. I started with UB now. Understood? If I give 5, 20, I'll get the output 22, 1. Okay. Now, I want to call this methods by using thread. Static void main. Let's create a task. Task T1 is equals to new task. And you're just going to pass the method details here. Method is parameterized or non-parameterized? With parameterized, how should I call? I said you open the braces, put a lambda expression, and then you require to write the method name. Method 1, 5, comma 20 is what I'm just giving. T1 dot start, T1 dot wait. Next. Yeah, that's it. No chaining, nothing. I did not use any chaining. Array, only one method I'm calling, that's all. And this code is nothing new. We already learned how to call one method by using one thread. How to call one method by using one thread. In the previous examples, if you have another method for calling the second method, I created second thread. Correct? With one thread, I did not call you multiple methods. I created a second thread. But no, with this thread only, I want to call my second method also. First method should complete. Afterwards, second method. Afterwards, my second method. So then we have the concept called as chaining. How do we do it? Dot. There is an option called dot. There is an option called continue with. Simple English here. Continue with. Continue with my second method now. Which method? Any method of your choice. Okay. How to write that? Antecedent, comma lambda expression now. No. Antecedent lambda expression method 2 5 comma 20. Nothing here. Just a minute. It's as simple as the previous one only. But how are you writing is, look here, how did you write here? This is how you write. Task comp in the constructor. Now you're calling a method. Which method? Continue with. And in continue with, you're writing now. But what is that? Just simple is, here you require to use a word called antecedent. Anything you can write here. Antecedent. What is the meaning of antecedent? Previous. Antecedent and descendant. Antecedent means previous. Descendant means next. So after completing the code of the antecedent, then execute me this method. So both are similar things only. Just watch it. Sorry, similar. But one thing is here, simple brace open enough. But here, we just require to use something. If you want to write previous, no problem. Any keyword you can use. After the previous, continue with this. Are you clear? But generally, what says is, they just use a word called antecedent. Antecedent means previous. After the previous, continue with this one. See, simple English. Continue with this method after the previous. After the previous method is completed, continue with this. Run this code. Watch. Start may not be called a continuation task. Writing something wrong. Let me check. Continue with. Same, huh? Method 2, 5 comma 20, right? And I write the code by calling start, called in a continuation task. Okay. So I cannot, just a second. I don't call start. No, in this case, compulsory, you're required to write code like this only, I think. Task dot, factory dot, start new. No, the first mechanism will not work here. Yeah. The first mechanism will not work here. Only the second way of creating the thread works here. The first way, what are two ways of creating the task we are seeing till now? The first one will not work here. Only you're required to do in the Second way, task dot factory dot start new. And first method got executed. See, printing from 1 to 20, 20 to 1. Both are combined up here. I want to give a line break between them. I want to give a line break. But are you calling these two methods separately? Put a line break in the middle. You're giving a continuation actions. Then how can I write array? Again, the same story. See here? Look, here you want a line break, right? Dot, look at carefully. Continue with antecedent, comma. What method you want to call? Console dot. Sorry, not comma, no? Lambda expression. Which method? Console dot write line. Console dot write line. Console dot write line. Again, dot continue with antecedent of so and so method. So in between, we are just going to add console dot write line there. So run it, and now three methods are executing continuously. First method, method 1. Afterwards, write line. Afterwards, method 2. This is how you can do chaining of the methods now. Chaining of your tasks, one after the other. So this code was to demonstrate you how to call multiple methods by using user created threads. Because in the video also I did not show you that. Until now, yesterday and also we did not discuss about that. What we are discussing is one thread calling one method. But today I showed you one thread calling more than one method. If you want to do that, you just require to call a method. What is the method name? Continue with, and you require to pass on the values. So here, what method you call? Start new. Correct? Here you call start new. Here what you call? Continue with. Here we call continue with. Console dot write line. Are you clear? This is how all of them has to be linked up with each other. Okay. Only difference is here the method name is start new. Here the method name is continue with. Start new doesn't require any keyword or anything, but here we need to use antecedent to tell previous. After previous, continue with this one. After the previous, continue with this one. If you remove the word antecedent, all the three looks the same only, see. Got it? Method name is different, that's all. But all the three looks same. Whatever extra thing is, just use antecedent. Otherwise, sir, it is a little bit confusing. Then use the word previous. You can write your name also there, no problem. You can write your name also there. There is no issue with that. It just asks you to write something, some keyword there to tell after the previous one, continue with this. Are you clear? So fine. That's about task chaining. Okay, chaining tasks using continuation tasks. Okay, finally, the last thing what we just have in our discussion is about async and await. These are very, very important, guys. Async and await. This is async and await. What is it, async and await? Okay, this is very, very important. Let me clarify you in detail. What is that async and await? All of you, if at all I want to do more than one task, if at all I want to do more than, if I want to execute more than one method, I repeat, if I want to execute more than one method, what are we doing? We are calling them by using threads, right? We are calling them by using threads. By calling them with the threads, we are able to call more than one method at a time. Okay. For example, just we do one thing, to demonstrate this one. Let me add another class here. Understand it. Without using threading, I can perform or I can execute the code parallelly. You will understand. Hold on a second. When I write my code, it will be better for you to understand. Guys, look at, I have two methods in my code. Public void or static void print is my method name. Print one is my method name. Static void print one is my method name. In this, no, test one. Anyway, see the code in that. What did I write? See that. What did I write? Console.writeLine starting reading values from database. And I want to read some millions of records now. Takes time now. How much time it takes, I don't know. So just for simulating, what did I do? I just put a delay of 10 seconds. I just put a delay of 10 seconds. Maybe let us assume like it is taking 10 seconds to read this. Okay now? Another method. My second method is, look guys, please enter your name. String name is equals to console.readLine. Next, console.writeLine. Name. And yeah, I'm printing the name value. Yes, two simple methods. Test one, test two. Now I'm writing the main method. No multi-threading, nothing guys. Just concentrate. Two simple methods you have written, that's all. There is no rocket science in the method. Simple code. Now I'll call the methods. Test one. Test two. What will happen? Sequential execution. First method executes, then control goes to second method. In this process, if the first method is taking more than the expected time, second one has to wait. Correct now? Yeah. The first method is taking 10 seconds to run. All the 10 seconds, second one has to wait now. Correct? Watch. Started reading values from database. 10 seconds, it is assuming like it is taking them 10 seconds of time to execute. After finishing, now the second method started execution and printed me the result. The second method started the execution and printed me the results. Are you clear? Okay. Name you entered is something. Just going to execute and print you. So this is no threading at all. There is no threading at all. See now what is the problem of the second method? Second method has to wait until the first one is completing its work now. First method is taking a lot of time to run. Today, 10 seconds is only imaginary value. But tomorrow it's a real database if we connect. Maybe it takes a lot of time to load the data from the database. It is going to load a million records from the database now. And database is very busy, not responding. It will take a lot of time to load. Sometimes you see web pages take a lot of time to load now. Yes or not? Maybe so many reasons. Your net speed may be good, but the page loading taking time. Reason? Because behind the screen, your page is going to load a data from database and database is not sending the data fast. Don't think like your network speed, your internet speed will impact your web page. Not only your internet speed here, the server speed also. Are you getting my point or not? If server is slow and you have 100 Mbps line also no use now. So performance should be on both ends. So here the problem what we are just noticing it is the second method doesn't require much time to run, but still the big problem what we are facing right now is it is just taking a lot of time to process. Okay, if you want to avoid this, solution is threading or task. Create two tasks now. Call the first method with the first task, second method with the second task. Yes or not? So two threads to be created. But in .NET 4.0, task parallelism introduced as a concept. What is it? With one thread only, doing multiple activities. with one thread only doing multiple activities. How, sir? How we can do multiple activities with the same thread? We are provided with the two keywords called as async, await. Async means asynchronous. Threading means what? Asynchronous programming. Threading means asynchronous programming means doing the work parallelly. One in the foreground, one in the background, asynchronous. So we have been provided with a keyword called async and await keywords. How do we use them? Observe it, all of you. On this method, just we require to use a keyword called async. Okay. Now, actually, which is going to take the time for you? This code is taking the time now? Yes or not? Here, we just require to use await. No need to call wait again. Just simply what you require to write is await. Async, await. Okay, watch it. Just run the code. The delayed time will be automatically calling the second method. See, the delayed time is automatically going to call you the second method. The delayed time will automatically call you the second method for you in this concept. What we call is async and await. First, we just require to call async, and afterwards, we just require to call the await on this. So what will happen? This 10 seconds of waiting will automatically used for calling the second method in this sequence. Will be used for calling the second method in this particular sequence basically. So if you run this, oh, I did not enter the name, guys. Hold on a minute. That is going to make use of that particular time to process it now. See, in between the code got executed off. Are you clear? See now, completed reading values from database. It is completing its work. Understood, all of you? So, did I use threading? No threading. The same thread only is going to do multiple activities. If you want to do that, you need to use two keywords. First, on the method, you need to use async. Asynchronous means I want this code to be asynchronous. Await. Await is a marker. What is that? To inform. See, basically when I use await and go to delay, means you're not doing any work. Transferring this thread to execute the next method. Okay. Now again, after 10 seconds that is ready now. Meanwhile, you're doing some other work. But this await is a marker to tell I'm ready, get back my thread again. And I'm free now. Take it. See, I'm just doing some work. I have a pen. I'm writing something. I need some inputs. To write. I did not get the inputs. Meanwhile, you came and asked me, can you give me your pen once? Okay, I'm idle. Take my pen. But guys, you're writing something. Meanwhile, I got my outputs. Meanwhile, I got my inputs. So I need to continue my writing now. So what will I do? Give me my pen back. Yes or not? Once my inputs are ready, will I wait until you finish? Huh? My work is delayed. I won't wait. So I'm going to tell you, I'm ready. Give me my pen back. So I'll take my pen back and start doing it. So this await keyword is to tell, I am ready. Just to send the control back to me so that I can continue my work again. So that's what the first method should be declared as async first. And then you require to use a await keyword. Okay. I'll show you a practical example for you how this async and await are used in the application development. This is a simple code what I showed, but I'll show you a much better example to you in the process of using async and await in your codes. Let me give you a better example about this async and await. Okay. So guys, all of us know Windows programming, right? We just learned about Windows programming now. So with Windows programming, I'm going to show you the async and await and how exactly this async and await can be used. Okay, fine. Watch. Let's close this project. Let's create a Windows project. New project. Windows Forms application. TPL project. I'm giving the same name, TPL project Windows. Previous one is console and now it is Windows. See, #9. Oh, I created a core project. Okay, no issues. Just a small example. Let it create. By default, we know that there is a form now. Yes or not? So by default, we have a form here. I don't require to give you an explanation for you again about this. And let us add 2 buttons on this now. Let us add 2 buttons on this. Just 2 buttons on this. Okay, 2 buttons. And setting the captions of the buttons as get length. Get length. Second button, say hello. Just like a call, say hello. And yeah, call, get length. 2 things, guys. And now go to the first button. Okay. And now here, I want to write my own user-defined method. I want to write my own user-defined method. Simple method. So what is the method name? Get length. The method name is get length. I want to call it where in the click of the button. In the click of the button, I want to call. No threading, nothing. Int result is equals to, what is the method name, guys? Get length. Okay. And then I want to show you a message. Message box dot show. Length of the string. Length of the string is result. So nothing complex. Length of the string is result. Second, a simple message box here, guys. Message box dot show. Just a simple message. So run the code. I did not write any great thing, just 2 simple button clicks. Message. Okay. See now, I'm able to move my form. You know this. I want to expand my form. Whatever you want, you do. No issues. Okay now? Now click on the first button. Which button? Get length. Okay. Now your form becomes unresponsive until it completes it. Now it is not moving. If you click on the call salo button, nothing is happening. Why? Single threaded model until that method executes, you cannot do anything now. That method should complete its work, show the output. Until then, you need to wait. See, this finished it. Now only this works. Yes or not? So what is the problem? Now it responses. But see, when I click on this method button, your form becomes unresponsive. Why? That is running a long executing code now, and this becomes unresponsive. I'm not able to move it. I'm not able to click on the salo button. Nothing works until the work is finished. That is the problem. So let it complete its work. Then only I can see the result. See, completed. Then only I can continue my rest of the works. So did you understand? The same problem I shown with the console application. There I manually explicitly put 10 seconds delay, but here I did not put any delay. The method has taken time to run. Suppose if I give some 2 lakhs or something, it will take a lot of time now to process. Are you clear? So that's what. So this is what. So I want the form to be responsive even while executing this code. I want my form to be responsive even while executing this code. So how to do that? How to do that is, you're required to make it as async. This method is async. It's an asynchronous method. It is a asynchronous method. Okay. Now, I'm just using a task here. Task T is equals to task dot factory dot start new. Which method? Get length. This method is value returning or non-value returning? Value returning. So if it is value returning, do you remember? You're required to use a generic type there. Correct? And here, the way you capture the result is not like this. How do you capture? T dot result. T dot result. Should I use for capturing? And guys, this result, when I'm calling this result, what will happen? The start new method will execute now. And when I call the result, the start new method will execute now. And it takes time now. And when it is taking time, it is not allowing others to execute now. Are you clear? And here I'm using await. Here I'm using await. Means start new. See, with this one is immediately going to release the resource to you. Sorry guys, not here. Should call on this method. Which method? Await T dot result. Await T dot result means what is going to happen when you are just going to call the result? It is just going to pass on the control to others. Means it is not going to hold the thread with it. It is not going to hold the thread with it. What it will do? It will simply pass on the control to the others. Pass on the control to the others. I'm sorry guys. It should be called as no need result. Simply await T. Await T. Await T. That's it. No need a T dot result also. So just we are going to call await T now. So now see the difference, all of you. Run this. When I click on this button, okay, now you called await on that now. So because you called await on that, it is going to leave the control when it is doing some work in the background. Means the control is not present with it. It will leave the control. And it will ask you back when it is ready. Until then, you do whatever you want. See, call. That is executing. But see, still this method is running. I'm able to move my form now. I'm able to do all these particular things. Are you clear? It will be ready. When it's ready, it will inform you. What will you inform? I'm ready. Send me the control back again. I will process my code. I will process. Giving you an example, you've taken my pen. Because I don't have any inputs, I'm freely sitting here. You've taken my pen now. So you're asking me, can you please give me your pen? Or I was talking on my phone. I'm filling an application form. Meanwhile, I was talking on my phone. You came there and asked me, you're please talking on the phone. Can you give me your pen, please? Yeah, take it. I disconnected my call. When I disconnected call, what I'll do? Give me my pen back. I am back in action. So this await is also same only. When I call await, what is going to happen? I'm ready. Send me the control back again. And I need to continue my work. So when I call avoid, immediately the control is bypassed to the other things which are going to be running in the code. So that is the advantage with async and await. First you require to call async, then await. Async and await. Are you clear? So these are the two new things which are introduced in .NET 4.0 with task parallelism, what we call async and await. We use them extensively, or we use them when we are working with MVC core. In MVC core, we'll be using them a lot. You're learning MVC, right? In MVC you won't get, but when I teach MVC core, these async and await methods I'll be using there. How to use async, how to use await, I'll show you practically. Yes, see, first example we did not, but second example is clearly demonstrated here. If I don't call them, what is the problem? Your form becomes unresponsive. To make it responsive, we just can for using the async and await keywords here. Is that clear, all of you? This is about async and await, and don't bother much about it. I will again demonstrate for you in the MVC classes how to use async and await in your code so that you can achieve the response when something is still executing in the foreground, and the background, it is going to perform an action to you. Asynchronous programming. Okay. So this is all about the async and await. Actually, if you have print out your notes, you have one more topic there. Yeah, that's removed off. That's why I did not explain you about that one. That was the removed off in the latest version. What is that? Task continuation. Huh? No. Task cancellation. That was got removed off. That's why I did not explain about that concept to you in the classroom. In your notes, it is present. If you want, you can practice that also. Just how to cancel a task in the middle. But that concept was removed off in the latest version. That's why I did not explain about that. Is that clear? So with this, we are done with C#. We are done with the C#. Okay. So only thing is, anyhow, you're continuing with the ASP.NET, but practice C# perfectly because we need all these things in our MVC classes. And one more thing I said here, you're done with this. So utilize your time now. Windows programming with link. I already said here. Okay. Videos are there. Just how to do Windows with link means inserting, updating, deleting without writing ADO.NET coding. You can use link code. I clear 7 videos are there. Watch them, practice them also. Is that clear? Okay, let's stop here. And we are done with this particular session. So we don't have a session from tomorrow. So we'll be just directly meeting in the MVC. That's it. Okay. Yeah, I will update the complete notes here. The complete modified notes I'll be putting